Hey there, it's Andrew with Campaign Blockchain, coming to you with a little video discussing blockchains, how they work, what are the components, and how they stay secure. Well, if we're talking blockchain, we got to go back to the beginning. So they were originally described in 1991 as a way to have a digitalized record or a digitalized notary. This would timestamp data or documents so they couldn't be altered with or changed in the future. This technique was largely unused until Bitcoin was developed by the person or persons known as Satoshi Nakamoto in 2009. A blockchain is a distributed ledger that's open to all. Anyone can go and view the blockchain, but there's specific things about blockchains that make it almost impossible to make changes. How does this work? Well, to learn that, we got to learn about blocks. So a block is a source of information, and each block has three components. It has the data contained within the block, it has the hash of the current block to identify it, and the hash of the previous block that came before. A block can contain any sort of data. In Bitcoin, the information stored in a block is the information on the sender, the receiver, and the amount of Bitcoin that was transferred between accounts. A hash is a digital fingerprint. It identifies the contents of each block. Each block has an individual hash depending on the data contained. If you make changes to the data within the block, the hash will therefore be changed. Now, how does this work in reality? Let's assume we have block 1, 2, and 3. Each block would have its own hash recorded, as well as the hash of the previous block. So if we had a nefarious actor who wanted to change some of the data in block 2, they would have to change the hash of the hash in block 2 and block 3. If that's not done, the changes in block 2 would not be accepted by the blockchain. Pretty incredible, and this is why we call blockchains immutable. But what if we have some very strong computing power, able to change the hash of block 2 and the hashes of every corresponding block after that? Well, this is why blockchains have an incredible solution to this called proof of work. Proof of work is a concept to slow down the creation of new blocks. For example, in Bitcoin, the proof of work usually takes about 10 minutes to add a new block to the chain. This proof of work concept forces that if you're going to change one data point and all the hashes corresponding, you also have to record the proof of work for each one of those blocks, making it near impossible to do all that computing power from one nefarious actor. Another way blockchains are secured is through a distribution known as decentralization. Decentralization allows for no single point of failure for the blockchain ecosystem. What this means is anyone can join, become a peer-to-peer networking node, and help secure the integrity of the entire blockchain. In this decentralized system, when a block is created, it is recorded throughout each one of the nodes. Everyone individually verifies this, checks it against their previous history, and verifies it's correct. So, to successfully tamper with Bitcoin or a blockchain, you have to tamper with all the blocks, change the hash for every single block, convert the proof of work for each block, and take 51% of all the peer-to-peer nodes and convince them yours is the correct one. Pretty tough feat, and that's why Bitcoin has never been hacked. Hope this helps you with a little bit more information on what blockchains are and how decentralization helps the world, and I'll see you in the next one.